and y are right. This morning we're looking at similar triangles, and as you can see from the board, we have what the similar triangles are. Say that when two triangles are similar, they have the same shape but different size. Also, the corresponding angles are equal. And here we have the example on the board. We have a small triangle and a larger one. Same shape, but they are different size. Alright? It says to prove that the two triangles are similar, the corresponding angles must be equal. What are we talking about? What we are saying, the corresponding angles where A is corresponding to X, angle B is corresponding to Y, and angle C is corresponding to Z. So if you notice down here, this is what we have. Angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. Since we have these, it therefore means that if the corresponding angles are equal, then triangle XYZ is similar to triangle C. We write, this is how you will write that triangles are similar. That's how we write it. Or you can just ordinarily say triangle ABC and triangle XYZ are similar. Okay. Alright? That may be a mouthful, but that's basically what similar triangles are. The corresponding angles must be equal, and the side of the triangle. Alright, moving on. Not only will we look at proving that the triangles are similar. Remember I said to the students that to prove that they are similar, the corresponding angles must be equal. Right. We also need to find the missing sides. Right? Alright, so up here now, we say that when two triangles are similar, the length of one side of the triangle is k times the corresponding length of the side of the other triangle, where k is a constant called the scale factor. One big mouthful, this is what I'm trying to say now. Going back over here, I am saying that if the two triangles are similar, then the length of one side, let's say xy, is in a ratio to AB. We want to know how big is triangle XYZ to triangle ABC. The scale factor K will tell you that. Right. So let's go over here now. Now we are given two triangles over here, where we see you are given all three sides. Right? But for triangle PQR, you are only given the side PR. Right? So we are asked now to find PQ, side PQ and side QR. But before we can find these missing sides, we must know what K is, because K is what we're going to use to find the missing sides. Alright? How do we find K? Let's go over here. How do we find K? To find K, it has to be the corresponding side of the bigger triangle over the smaller triangle. Alright, let me say it in layman terms. Alright, so the triangle side PR is corresponding to AC. And the side QR is corresponding to BC. The side QP is corresponding to AB. Alright, so notice that we have no measurement for QR, and we do not have any measurement for PQ. We must find these. The only pair of sides we have is side AC and PR. But to find K, it has to be the corresponding sides, and the large one over the small one. So you have, back over to the first part, you would have, to find K, you would have to put XZ over AC, or you can put YZ over BC, or you put YX over BA. Right. So that's what we have up here. To find K, that is what you have. No, you have to look at the signs and see what we are doing. Alright. So from there now we can go back to here, and we want to find K for these two triangles here. right? So to find K now, as I said, the only pair of sides that we had was PR and AC. So to find K in this case, now we have to put PR, remember use the bigger triangle over the smaller one. So it's PR over AC. So it is 9 over 3, which gives me 3. Now it doesn't have a measurement, a unit, it is just 3. What does this 3 mean? It means that the size of triangle PQR is 3 times the size of triangle ABC. Alright, let me repeat that. When you find K, whatever number K is, it tells you that bigger triangle is that number of times the size of the smaller one. So in this case, PQR is 3 times the size of triangle ABC. I hope that is clear. Alright, since we have now found the scale factor K, we are now asked to find the missing sides PQ and the other missing side QR. Alright, so since we have found K, we find the missing side, since we have found K now, which is 3, how do I find these missing sides PQ and QR? Alright, to find PQ first. PQ, now what is corresponding to PQ? Which side is corresponding to PQ? The side AB is corresponding to PQ. So, for me to find PQ, it has to be the scale factor K times the side that you know, which is AB. So it's going to be 3 times 5, and that will give me 50. Remember we said that PQ, triangle PQ, is 3 times the size of triangle ABC. So the size must be 3 times of that, of ABC. So PQ is 15 centimeters. To find QR now, QR corresponds with BC. So BC is 4 and K is 3. So 3 times 4 would give me 12 centimeters. And so PQ we know to be 15 centimeters and QR is now 12 centimeters. We can also be asked to find the area of the large
3.
Okay, so I'm saying now, after we have found the missing sides, we can also be asked to find the area of the large triangle. Right? Okay. For this, we also need K. So, to find the area of triangle PQR given that the area of triangle ABC is equal to 6 centimeters squared. Right. So area of triangle PQR is equal to K squared times area of triangle ABC, which is equal to 3 squared times 6. 9 times 6 equals 54 centimeters square. I know that what we have done today is a mouthful, but let's recap what we did. First, we looked at what similar triangles are. Right? So that 2 triangles are similar if the corresponding angles are equal. Okay. Then we looked at how you prove that they are, apart from proving that they are similar, we look at how we find the missing sides, right? And to find the missing sides, we must have the scale factor. How do we find the scale factor? It is the side of the larger triangle over the corresponding side of the smaller triangle. That will give you K. After we have done that, we moved on to looking at how you find the area of the triangle, the missing triangle. So to find the area of the large triangle, you must be given the area of the smaller one. or you find it from the values that you have, right? And so after you found that now, try to find the area of the larger triangle. It is k squared times the area of the smaller triangle, and that will give you the area of the larger triangle. So, okay students, that is it for today's video. Next class we will meet, we will look at some examples working out to prove that two triangles are similar, to find the missing sides, and also to find the area of the triangle.